Hello children, now we are going to work on our second experiment that is related to light. So we have done the concepts of refraction, and in refraction we have done the specific cases of glass slab and prism. So the second experiment is related to glass slab. In this experiment we are going to work on the refractive index. We'll be finding out the refractive index of glass with respect to air using Snell's law. And we'll be proving angle I is equal to angle E, and we'll be measuring lateral displacement in glass slab, and we'll also work out how lateral displacement depends upon angle of incidence. So for that, this is the apparatus, this is the glass slab, a plain sheet that I have just pinned up here. We'll be using protractor, scale and these all pins, right? So how we are going to proceed? First of all, we are going to draw the outline of this glass slab, right? And after drawing the outline, we'll just remove it because I need to draw different angles. I need to draw an incident ray, and it is not that only one reading is required for this. At least 3 to 4 readings we work on it, right? But I'll be just showing you one reading, and I'll be then giving you observations of different values. So first of all, I'm going to draw a normal here, right? So generally children have this concept because it is normal means we have to simply draw a straight line. So using scale you can draw, but we don't prefer because we are working in lab. We want perfection, and to draw the angle, I think protractor is the best option, right? So because even if there is going to be alteration in 1 degree, there is going to be alteration in your result, right? Since it is normal, I'll be drawing dotted line, right? And I'm naming it as NON dash. Now using this, I'll be taking an angle of incidence, right? And it can be any angle. Right now, suppose I'm opting for 40 degree, right? I'm marking here 40 degree, and I'll just draw the incident ray here, right? So this is your incident ray. And angle between incident ray and normal, okay, let me label it as AO. Angle between incident ray and normal is known as angle of incidence, and here angle of incidence is 40 degree, right? Now I'll be placing the glass slab again here in the margin where I've drawn the outline of the glass slab, but before that I'll be fixing up the all pins here, right? And what is the purpose of these all pins? Actually, this incident ray and these all pins are denoting a ray, right? They are representing a ray of light. And when I'll be putting this glass slab back to its position, I have to view these 2 pins through the glass slab. Why is it so? The thing is because we are working on the phenomenon of refraction, right? And here it is from air to glass, this thing is happening. So if I want to see the behavior of light through glass, it means I have to view these 2 pins through the glass, right? So let's see how it's going to behave. Let me try if I can show you. Can you see here the 2 pins? The 2 pins are here, but if you check out the 2 pins through the glass, they are displaced from its position, isn't it? So why is it so? Because this is simply showing you refraction. This is just an example that suppose you have a glass filled with water and you put a pencil, a spoon in it. You can see that the spoon, it seems to be broken, it seems to be thick, and it seems to be raised up from its position because of refraction, right? So this is, now the thing is, you can see these 2 pins. Now I'm just going to adjust the 2 pins and my position in such a way that these 2 pins are one after other. And now again I have to adjust 2 more pins in such a way that all the four pins, I just find them in a line, right? So if you can see here, I hope so you're able to make out. These are the 2 pins. I'm viewing it through the glass slab such that the 2 pins are one after the other. Now I'm going to adjust these 2 pins, okay? So just give me break. Now I have adjusted the two more pins such that the previous pins and these two latest pins that I have just fixed up, they all are in a straight line. I hope you can see. Plus you can actually see the pins lying on the other face of the glass slab, right? So from here only you can make out refraction. So these are now all the 4 pins are in a straight line. Now I'm going to remove all the 4 pins and I'll be just putting a circle around the impression so that I can make out the position of the pins. Okay. See, I've removed the pins and I have just encircled the impressions, and I'm removing the glass slab and again encircling the impressions. Now what I'll do, I'll just join the ray that I got it. Again I'll be joining these two, right? So now this is incident ray, I'll label it as B, right? And this is as C. So OB is representing refracted ray, BC is representing emergent ray, right? Angle between normal and refracted ray, that is angle of refraction at the first surface. Again here I need to draw a normal, right? And this is your normal. This is your normal here, right? So using protector only I'm making. So this is going to be your normal, right? And this is angle of refraction at the second phase. This is your refracted ray after refraction. The ray that emerges out is termed as emergent ray, and this is your angle of emergence. So what all we have to work out? I mean, what is the aim of the practical? The very first thing is to find out, using Snell's law, the refractive index of the medium. And as I know, refractive index is given by sin I upon sin R. So I have already fixed up the value of I, that is 40 degree. And now I have to find out the value of R, and then I'll be finding out sine of that R, right? Using log table, trigonometric values, I'll be finding out. This comes out to be 40 degree, and this I have to find out. I'll be doing that afterwards. Second is, I have to prove that angle I is equal to angle E. Angle I have already taken to be 40 degree, and angle E, if you measure here, it again comes out to be, you can see here, it again comes out to be 40 degree, right? So you can see here, this again comes out to be 40 degree. So again, I have proved that angle I is equal to angle E. And the third part is that we have to find out the lateral displacement. For that, if you remember, we have done the concept that for that I need to extend the incident ray. When I'll extend this incident ray, the distance between the emergent ray and the extended incident ray is your lateral displacement. And I have to find out what is the measurement of this. Right now it comes out to be, for the measurement of angle I 40 degree, lateral displacement comes out to be, this is the third part, lateral displacement comes out to be 2 centimeter. Now fourth part is, I need to find out how lateral displacement and angle of incidence are related to each other. Angle of incidence and lateral displacement, how they are related to each other. Whether directly proportional or whether inversely proportional. This is what I have to find out, right? And for that, again, I have to take different readings. Like here I have taken angle of incidence 40, next time it may be 30, 45, 35 and so on. So at least 4 readings are supposed to be taken, right? So I'll show you because I'll be working now, and then I'll give you observation table. You will be able to conclude that how the dependence of the two are there, right? So this is your second experiment that is related to glass slab. Okay, so I'll be substituting the value. I'll be measuring this, and we'll be able to find out the refractive index, because I know refractive index of glass with respect to air is given by ratio of sine of angle of incidence to sine of angle of refraction. So here, as I'm getting, I think it's 22, I think. So okay, I'll be finding out the value for these two, and then I'll be finding out the ratio of the two. Okay, so thank you.